All right, hello and welcome to a new lecture. We're going to finish up these slides that are titled containers by talking about something completely different to containers, okay? So let us get started there. I want to teach you about two things, SSH and SCP, all right? And they, do I tell you these? Yes, I do. I tell you what they mean on these slides, so I won't write it out. So they're very, very useful things. Actually, when you're turning in your assignment, secretly I'm using SSH and SCP for you, okay? Believe it or not. So that is the idea. So SSH stands for Secure Shell, okay? It lets you access another computer from your own computer, okay? So we have our class server. It's called server.lawtonsclass.com. I didn't give myself nearly enough room to write it. I'll just write some ... dots. That's another computer that you can connect to from your own computer, okay? And you're actually doing that whenever you turn things in, and you can get a terminal there, okay, by using this thing called SSH. So if you want to get that terminal, all you need is an account on that server, and you do. You have one. I've given it to you, right? And that's what you use to turn things in. That's your server username and password. So you have to have the username that you want to connect, and then the address of the computer you want to connect to using SSH. So that's our server.lawtonsclass.com. And we can use SSH. It's a command on your computer, on your current terminal. And then you say space, and you say username, and it's like an email address, username @ and then the computer you want to connect to. So server.lawtonsclass.com. And then you have a terminal on the other computer. Isn't that crazy? And yeah, then you can say exit once you're done to get back to your normal terminal, or you can use Control-D, or you can just go the nuclear option and just click the X on your terminal and just close everything. So let me show you SSH. Let me show you your accounts on the class server. You've had them. You've had them all this time. You've just only probably been using them to turn in your assignments. So let me show you these, okay? And I want you to understand SSH, because it may just so happen that in a future class you're required to connect to a server using SSH. We're actually getting a fancy new server for our computer science department, and so I'm probably going to start requiring my future students to use SSH to get those, to get a terminal there and just work there. Okay, so you can do all your labs on the server if you want to, and I encourage you to try. So it's SSH space, then the username you want to connect to. So give your class username and your server username, and then you say @ server.lawtonsclass.com. Then you hit enter, and then it will ask you for your password, and as usual you won't be able to see it. You type it, and then you're in. Okay, so it's a little bit of a welcome message. It shows you, okay, welcome to all this cool stuff. Here's, like, this is one big server, and so like a bunch of people are using it. You can see, like, okay, there's nobody else here right now, it's just me, so there's no load. There's some memory being used by probably the auto grader, things like that. Yeah, this is now a terminal, not on my current computer, but on the server, okay? So it plops me into my home folder there, okay? Print working directory. I have a home/my username folder, and you do too. And this is yours, okay? Your home folder is what you get to use to place things there, okay? You're usually working in your home folder. You don't have access to the other folders, okay? So you're going to be plopped into your home folder when you go there, okay? Maybe I should write that. And the shorthand for that is tilde, okay? So yeah, you can do all the normal stuff that you've been doing on your terminal here. Okay, so let me make some files. Be like, I don't know, there's nothing there right now. It's an empty folder if I say ls, but I can add things. I can say vim or nano, I don't know, hello.cpp, and we'll write a hello world program. So include iostream using namespace standard, int main, cout, hello world, new line, return 0. Yeah, so there's my file. Right, quit, save it. Now it's there, and you can always go back to it, of course, but we can compile it. G++, standard, equals C++17 hello.cpp-o hello. And all of this is happening on the server. This is not your current computer anymore. And so now I have made this new file. I can say /hello. Bam, it's hello world. And I'm sitting on the server right now. Okay? If I go to my home folder on this computer, it's a different folder, and ls has a bunch of different things. It's not the same computer right now. I'm connected to the class server, and I'm making files and running programs. Isn't that cool? So that is, excuse me, that is SSH in a nutshell. You can connect to another computer. You can make another tab and connect to the same computer again if you wanted to. Not a problem. But I'm connected to the class server right now. And I can make directories, make dir, test, whatever. Now I have a test directory. I can move things into there. I can do all the cool terminal stuff that I encourage you to look at I posted at the very beginning of the class a little guide for how to use the terminal if you're still wondering about how to do all this stuff. So now I've moved that into test. I can cd into test and see what's there. It's all wonderful. Okay? So that is SSH in a nutshell. Do give it a try because you might be required to use it in the future. Okay? It's a very common thing to do at a four-year college to make you turn in your stuff at like the campus server. Okay? That's the idea. And once you're done with your terminal, you can either say exit or Control-D to quit out of that session on the server. So I can say exit, and now it logs me out. And now I'm back on my normal computer, my local machine. Okay? Now I'm in this folder. That's the idea. Okay, so that is SSH. If you want to know more about it, you can always say man SSH. Look at the manual page for it. So yeah, that's what it is. And now the other side of the coin to SSH is a program called SCP, and that stands for Secure Copy. You've used CP to just get your your code, your starter code, right? To copy files. SCP copies files from a remote computer to your own, or the other way around. Okay? You can copy files between your remote machine and your local machine. Isn't that cute? So yeah, you just use it exactly like you would use it, use the normal CP command, but you just give it a bit of extra info about where it is on the remote machine. Like the file, the actual full file on the remote machine is username at the machine, and then a colon, and then you give the file path. It's like in the home folder, I want this file. Please copy it onto my local machine in the current directory. See that? That is the idea. So let's copy our hello.cpp file from the server into my current working directory. Okay? And again, you can say man scp to figure out how to do all this stuff. Like, it'll have some examples, this is how you use it. I'll hear all the different options you can use. It's very fun. So yeah, that is SCP. Let's use it like CP to just copy back what we had. Okay? So I'm going to say SCP, what do I want and where do I want it? So I want that hello.cpp file, and I want to put it in my current working directory, but this hello.cpp file is on the server. So where exactly is it? It's at test 0867539 at server.lawtonsclass.com : and then it's in my home folder, and it's the hello.cpp file there. Okay, I want to copy all of that one file to my current working directory, which is the dot. Okay, and if I hit enter, it'll ask me to for my password, and then bam, it transferred it. And you've seen this kind of stuff before because this is how I download your grades, right? That's the idea. And so now, look at me. I have hello.cpp on my current computer. This is not the server. It's my current computer. I can edit it here. Go back and forth. Isn't that cool? So that is SCP, Secure Copy, in a nutshell. Okay, so yeah, that's just another terminal command that you can use. You can use use it in either direction. You can copy it from your computer to the remote machine, or from the remote machine to your computer. Either way. You can actually copy from one remote machine to a different remote machine if you really wanted to, I think. So that is SSH and SCP. Do look into them because you will probably be required to use them one day. Okay? So the last stuff, the exercises that I have for you for these slides are, I would very much recommend you to try and come up with some examples yourself of when you'd want to use like a vector versus a list versus a set versus a map over the others. Okay, when is it best to use a vector? Maybe when you want to get at a certain index very quickly, because it can do that fast. When do you want to use a set over a vector or a list? Well, maybe when you want that ordering. You want to know very quickly, is something there? Otherwise, you'd have to search through the vector, search through the list. Yeah, that's the idea. And then if you're feeling brave, I do encourage you, I'd be happy to help you as much as I can. Try doing your next lab on the server. That would be perfect. Turn-in works just fine. It all works. Try doing the next lab on the server. It will be a very good learning experience, I think. Okay? That is what I have for you. And that is the containers lecture. So now let me go set up the next lecture, and I'll be right back. All right, so this is an exciting set of slides I have for you. It's called Beyond C++, because we're going to learn something other than C++ now. We're going to learn two different programming languages. I have Java and Python to teach you. All right, I think we'll only get to Java today. I'm sure we'll barely get through Java, but yeah, are you ready? This is wonderful. My promise to you, though, is this is brand new stuff, right? Brand new stuff, very close to the final. So if I test you on any of this, it's going to be very, very simple, okay? Very, very simple programs that I go over, like this Hello World program and like a class that I'm about to implement, maybe a counter class. We'll get into that. That's the level, okay? Nothing super duper hard. No fancy libraries that I'm going to show you. None of that. So that is my promise. All right. So don't fret too hard. Just try and sit back and take this all in, because it's good to know multiple languages. And it's also quite possible that whatever school you transfer to had Java taught to the students instead of C++. Some people like to do that. So it's just good to know. And a lot of programs, they like to teach Python first. So this is why I'm going to teach you all of these things. Okay? Are you ready? So yeah, I guess the first thing is, if you're really interested in this stuff, if you know you want to learn Java, like you're going to make an Android app or something, I encourage you to look at this first link, this Learn X and Y Minutes link, okay? Because they have a lot of nice things for all of these little programming languages on this website, okay? So here's a bunch of stuff. Here is Java code. It's all highlighted and beautiful. And it's showing you like what's going on, all the different types, all the different ways to make functions. Right now it's just working with basic types, how to print things, if statements, loops, etc., classes. They all look very similar, right? That's all. You got some braces, you got some dots and things, you got some function calls. They're all very similar stuff, okay? So don't worry too much about this. Java is actually surprisingly similar to C++. All of these object-oriented languages, the ones that revolve around making classes and using classes, essentially, they're all the same, okay? So, yeah, enjoy the nice meme, and let's do Hello World in Java, okay? So, let me make Hello World the program for you, and then I'll explain it thoroughly, all right? So I'm going to make a helloworld.java file, okay? Helloworld.java. Are you ready? So that's the standard thing to do. You make it like all capitals. Have the little when it's a new word, you make a new capital. That's the standard thing to do. And so I'm going to make this Hello World program. All it's going to do is print Hello World. Are you ready? So public class Hello World, and then I'm going to make a main function, and it's called public static void main, and its arguments are the string. It's a string array of arguments. Okay, so this is how it gets its command line arguments. Okay, so that is where the main function is. There's even a main function in Java, just like there is in C++. And then I'm going to print to the screen, hello world. Are you ready? System.out.println hello world, exclamation point. And it's called print line, which means it's gonna do the endl for us. It's gonna do the \n. It's already gonna give us a new line. That is the program. That is hello world. Okay? There's some new things. Don't worry, I'm gonna explain them, but that's what we got. All right? So that's the program, and then we can compile it. Okay? Java is both a compiled and a not compiled language. I can get into that more if you're interested in office hours, but Java programs, before you run them, they get compiled into what's known as an intermediate representation, okay? So that it can run wherever you want it to run. We'll get into that maybe a bit later. But all you need to know is you can say Java C, that stands for Java compile, C for compile, and then you give it the file that you want to compile, okay? So I'll say Java C, hello world.java, hit enter, and it has made a new file for me called hello world.class. Okay, the .class is like the compiled form of the hello world program, hello world.java program. Okay, and .java is the extension for Java programs, Java source code. Okay, so yeah, let's talk about all of this stuff. All right, the very first thing that you need to do when you make a Java program is the names are very important. This means if you call your program hello world.java, the class that you define inside of it must be called hello world. Okay, these have to match. This and the public class hello world need to match. This means you need to write public class hello world. Okay, that's what that implies. Okay, if I were to change this, I'd get a compiler error. If I made it like lowercase w even, watch. It's already giving me an error. It's warning me. Oh man, it's going to show me this. You have a class called hello world. It's public. It should be declared in a file named hello_world.java. You see how crazy it is? It really it requires all this stuff. Okay, so we need public class hello world with a capital W. Can't be anything else, otherwise we have the wrong file name. Okay, so the file name is very important, and now it's happy. And so that's the first thing. Okay. And comments are exactly the same as they are in C++. So you can have the multi-line and single-line comments in the same style. So all classes, or all programs, let's say, in Java are part of a class. Everything you write, let's just say that. Needs to be inside of a class. So if you want a main function, it needs to be inside of a class, and every Java file, every blah.java file needs to have one public class, needs to implement a public class called blah. Okay, they're all the same names. The names have to match, and public just means it's visible to everyone. Okay, just like in inside of a class. Just like C++'s public colon. You remember that? Maybe I can use the quotes after all. Yeah, that's the idea. So yeah, that's public class hello world. That's that part. And now let's get into the main function. Okay, so the main function, if there is one, needs to be part of this public class of the same name. That's the file, and it doesn't actually return 0. That's the first new thing. It's a void function. Okay, technically it's a method because it's part of a class, but it's a function to us, right? And yeah, Again, it's public so that the whole world can see it, and then it's also static. The static part just means it belongs to the class. You can have static things in C++, we just didn't teach it. Static means that the main function, I guess we should really say method, right? Method belongs to the hello world class itself and not to any hello world object. If you were to make a hello world object, main doesn't exist in all of them. It's just part of the class itself. So technically, you'd call it like hello world dot main. That's how it's getting called. It's not like, okay, first let's make a hello world object HW and then let's call main on it. It's the first one, okay? This is the one. That's what's really happening. It belongs to the class itself, okay? That's what static means. It doesn't belong to an object like this. It belongs to the actual class, okay? It's just part of it. So that's why we treat it like a function. And then we have the one argument to main always needs to be the command line arguments. And those are given as an array of strings. Okay, so it's capital string in Java land, that's all. And then we have the body, and all the statements have semicolons at the end of it. It's all quite nice and similar. This is how you print things. To print, you just say system.out.println is of blah translates to essentially cout blah with a new line attached to the end. Okay? That's what system.out.println does. It's part of the Java standard library in the system module, in the output part of the system module, and then it's the print line function in that library, in the output library. Okay? And that's the idea. And then you just give it the string you want to print with the same normal syntax that we have for strings in C++, and then it says hello world. Okay? So that is the program. That is a ton of comments. I hope that helped. All right? That's the idea. And so we've compiled it. We've compiled it into hello world.class. This is technically not ones and zeros at this point. It's a compiled file that can be run on what's called the Java virtual machine. So it's not quite my computer's processor specific yet, if that makes sense. But all you need to know now is to run it. If you want to run it, instead of javac for compile, you just say Java to run. You say Java hello world without any extensions. It knows to go and look for the class file. Okay? It knows to go and look for the compiled class file. So this is just going to run that file now. Are you ready? Whee. So we say Java, and then we say space hello world. And then it's going to go and run the program saying hello world with a new line. That was a lot, right? But it was really technically only like 3 real lines of Java code. So not too bad, I hope. But that is Java. That is our first taste of Java. Okay? So you compile it from the Java file, the implementation file, to the class file. Then you run the class file with the Java command. Okay? That's all. That's how Java works. And the main function is what it's going to run when you run it through the Java program. It's going to look for the main function inside of this class. Okay? That's the idea. And one really, really nice thing about Java is that like the documentation is built in. Like it's not some other website like we have for C++ who's writing up all this documentation for all of these library files and functions and classes. No, it's actually the makers of Java, Oracle. They're writing the documentation themselves. Okay, which is nice. And so we have all this stuff that tells us about like what we have. All right. So here is the java.lang package or module or part of. It's a little piece of the Java language. So Java is a package. Inside of that we have a lang package. So these are the fundamental Java language features, And so inside of java.lang, that's automatically included for us. Then we have system. Okay, that's where the print line is. So we have the system class contains several useful class fields and methods. That's nice. Okay, let's see what it has. It has streams and things that we know about. It has a bunch of useful things that it can do. Can like get the time and all that. But what we're interested in is out, the standard output. Okay, so we do java.lang.system.out.println. Okay, so here is out. It's a print stream, and so that's its class. Let's see what print stream can do. It can print lines, and we can give it a string. It knows how to print a bunch of different things, one of which is strings. And so it prints the string, and then it ends the line. So technically, this system.out.println really is, this is java.lang.system.out.println. Isn't that a mouthful? All right, so that is all that I can squeeze out of the Hello World program, I think. And that is the documentation. You can look into this for whatever you're interested in, and there's a really good library in Java, so probably what you're looking for is already implemented for you. Okay, so that's Hello World, and let's move on to this slide now. All right, so Java is a wonderful, magical language, but things are slightly different in it, okay? In Java, the big thing is that everything, maybe I should say almost everything, essentially everything, almost everything is a class. There are no pointers, which is quite nice because maybe we don't like pointers, and arrays look a bit different. So that's what I want to talk about on this set of slides. So let me give you some examples of these types, this int double bool type, and then we'll go to strings and arrays. Okay. They're almost exactly the same, but not quite, right? So let me make a file called, I guess, morejava.java. And so you know what this has to be now. It has to be public class morejava. That's exactly what needs to happen here. And for the main function, it's all the same. It's public static void main and then string with a capital S, bracket, args. They put those brackets in a different spot, don't they? So we'll get to that in a second. But yeah, let us continue. And it's quite nice because you don't have to say return 0 all over the place. It's just do what you want the main function to do now. And I guess the first thing is, let me show you the stuff that is the same. Int x equals 42, that's fine. X++, that's fine. I can't say cout now, though. I can say system.out.println, though. I can print x if I want to, just like this. Just the value of x. And so how do I compile this and how do I run it is the question, the age-old question. I say javac, and now it's more java.java. Okay, and that made morejava.class. Very nice. And I can now run that with java morejava. Okay, that's how we do it. No more dots and slashes. Okay, and so it's 43. These are all the same as you would expect in C++. Okay, what's the next one? Doubles. Those are also the same. Double y equals 3.1415926535. We can do stuff with that, of course. Same stuff. Y equals y minus 1. I don't know. Or y times -1. How about negative pi? And then we can say system.out.println y. Not too bad, right? Doubles exist. I can recompile, rerun, and it all looks as it should. Okay, that's ints and doubles. And now this is where it gets weird. Slightly different, and it will trip you up the first time. Booleans are not just bool. You have to add the ian part as well, okay? They like you to spell it out. So you got to say bool, ian, boolean, b equals true. Yeah? That's the idea. B equals not b or something. So this should print false. I wonder if it's still in there. Nope. System.out.println Okay, so it's got to be Boolean instead of bool. It looks different, ever so slightly. And we get our false printed out. And it actually prints false instead of 0. That's quite nice. Sometimes we like that. You can configure C++ to do it that way, but it takes a bit more effort. Okay, so that's booleans. And then strings. Okay, strings are capital S. String S equals hi mom. And we can say things like S equals S plus the single exclamation point character. And then we can compile and rerun, but maybe I should actually print something this time. System.out.println s. Okay, so that is that and that, and now it's hi mom with an exclamation point. So those are like the 4 main types that you're ever going to use in Java. And let me talk about arrays in a second. Let's first talk about how Java is running. Okay, Java, it runs on what's called a virtual machine. Okay, so really, when you compile your program, your more Java .java, that's the actual code, like public class more Java ... When you say Java C that, you make what's called a class file, more java.class, which is binary, like it's not readable by a human anymore, really, but it's not something that can run straight on your processor like it is when you use G++. This is what's known as bytecode. Bytecode, Java bytecode. And it needs a special extra thing to be installed in order to run it. It needs what's called the JVM, or the Java Virtual Machine. So secretly, when you run a Java program, it's running its own little virtual machine, just like we've used in this class to run Linux. So you send it to this. It's like, okay, I know how to load a class file and translate it into code that your computer can actually go and run. Okay, so it runs everything for you. Okay, it translates it immediately, all this bytecode, into processor-specific code. And it's more or less the same speed, a little bit slower than C++. Okay, so that's the idea with the virtual machine. I told you about the downside, it's a bit slower, but one nice thing about compiling Java programs is that once you've said Java C and you've made this .class file, your Java programs can run on any computer with Java installed, because it installs this virtual machine thing. And this is very, very different to C++ programs that have been compiled, because those are specific to an operating system and also a CPU architecture. So like, if I compile my C++ program over here on Linux, even though I'm running it, I can run it on my current computer's processor. I can't just copy that file into my Windows drive and double-click it and have it run. It just won't work, because the operating system is different. And it's even different when we're trying to run the same program on our phones, which have a different kind of CPU architecture. Okay, so that's the idea there. It has a fancy virtual machine. Okay, it's not really fully compiled, if that makes any sense at all. Okay, so yeah, now it's time to talk about arrays. Are you ready? So for arrays, what you do is you say, instead of int arr bracket bracket, you say int bracket bracket arr. Okay, just like up here. Just like string array args, you say int array r, which kind of makes more sense because this is the type, right? It should all be together. Int array r equals, and then we say new, we have to make it on the heap, new int array. And you can give it its values. It's like 1, 2, 3, 4, whatever you want. And now we have an array made in Java. Okay, compiles, it's happy, it's got that array arr, but it's made on the heap. Isn't that crazy? And so that's the first thing. You do have to say new all the time. Let me, let's see, how do I want to say this? Maybe I want this one first. That's what we're talking about right now. And then I'll get into the fact that you don't need delete anymore. It's very interesting. So let's go through this array right now. Let's iterate through it. So you can have a for loop in Java. You can say for int I equals 0, I is less than, I could say 4 here right now because that's the length of the array, or actually in Java arrays know their sizes. So you can say arr dot, I'm pretty sure it's length. Let's find out. It's been too long. Yeah, okay, it was length. Arrays actually know their size. That's quite nice. It's like a little field inside of an array. And so then I can output system.out. I can just say print instead of print line to print the I, and then plus maybe a space. And so then they will all be on the same line. And then to print a new line, I can just say system.out.print line with nothing, and it'll just print nothing and then a new line right after. Let's see if that's happy. Yeah. So, yeah, here's printing 0, 1, 2, and 3. Oh, I'm so sorry. I need to print the actual array, don't I? Let's go into it. ARR, bracket I. Same notation. Okay, nothing different. It's just the way we're printing it is slightly different. Okay. So it's printing 1, 2, 3, 4, which is correct this time, sorry. And that is arrays in a nutshell. You gotta say new. You gotta make them on the heap. Okay. And one extra nice thing about Java is, you know how we have our stack and our heap. Anything that you make on the heap in Java, yes, you say new. First of all, you don't have to get pointers back. It just does it all for you. Everything is like a reference, it says. So you don't have to like make this a pointer to an int array or anything. It just is happy. And secondly, we don't ever have to call delete. There is no delete in Java. Java is what's known as garbage collected. It notices, the runtime, the virtual machine notices when you're done with something. It knows that you can't reach it anymore. And it deletes it for you. And this is exactly why we don't teach you Java here, because you can get into very bad habits, okay? Not knowing where your memory should be deleted, okay? That's why we teach you C++. So yeah, Java's quite nice. It's garbage collected. You can say new whatever you want, as long as that thing that you want is either an array or a class, okay? Ints are not, so you can't say like new int anymore. But Java kind of solved that problem with a different integer type. But that's a little too much. The idea is you can make arrays on the heap, whatever you want, as many as you want. AR2 equals new array, I'm sorry, new int, bracket, bracket, and then you can give a size, like, okay, I want 42 things in this. And then you can start using it. Be like AR2, it's on the heap, it equals 3, and maybe AR3 is going to be 4, and AR4 is 5. And when you go and iterate through this, you're in for a treat. Notice, I have skipped several indices in this array. Yes? Nevertheless, watch. Watch what happens. Java's a bit more sane than C++. Oops, what did I forget? Exception, out of bounds, dun dun dun. Where is the problem on line 33? Oh, sorry, I've been using ARR instead of normal ARR2 that we just made. Excuse me. There we go. And notice that there are zeros in every other spot. It's not undefined. Java just puts zeros everywhere that you didn't have something. Okay? So there's no more like undefined behavior. Anything that's been declared but uninitialized is zeroed out. It's quite nice. So yeah, that is what you get from Java. Sane defaults. And I think that's where I want to stop today. I've blown your mind a little too much, probably. It's all very similar and yet very different at the same time, isn't it? So this is Java, all its basic little types, and when we come back next time, we will discover the magic of Java classes, like how to go in and make our own classes in Java. We'll make a nice counter class. Okay, that's a good first one to make. So that will be what we do next. So yeah, that'll have to be saved for next week. So I will see you then.